Let's do some examples of finding the volume of three-dimensional shapes. Let's take a look at this first shape. Find the volume. Now remember that volume is measured in cubic units, since now we're measuring capacity, which would be in 3 dimensions, length, width, and height. So how would you approach finding the volume of this shape? You may remember a formula, or you may have to refer to it to make sure you've understood where it comes from. First of all, identify the type of shape this is. This shape is a rectangular pyramid. I know it would be called rectangular because the base of this is a rectangle, since it's 15 meters by 12 meters. It's a pyramid because it's 3-dimensional, and the lateral faces are triangles that come to a point. So if you have previously derived the formula for the volume of a pyramid versus the volume of a prism, that could really help you. So remember, the volume of a rectangular prism is just length times width times height, or the area of the base times the height for any prism. So if we have a pyramid, and you did one of those derivations, maybe even using an experiment where you used water to see how many pyramids it takes to fill up a prism that has the same base, well, the formula turns out to be 1/3 the area of the base times the height. So we need to find the area of this base, multiply it by the height, and then multiply it by 1/3. Try that and check your answer. All right, so there's the formula we talked about, 1/3 capital B times H, where capital B is the area of the base. So in this case, the base is a rectangle, so we can do base times height, which is 15 times 12, and we would get 180 square meters. Now we have to multiply that 180 square meters times 1/3 and times 20, and you should get 1200 cubic meters. Now notice that I put units throughout my formula because this is really attending to precision and reinforcing where cubic units come from. So for example, when we multiply meters times meters, we get square meters. When we multiply square meters times meters, we get cubic meters. This is really laying the groundwork for algebra. Let's do another problem. Find the volume. Again, volume is measured in cubic units, and so we're in 3 dimensions, length, width, and height. Now, the derivation for a sphere is fun, and I hope you've gone through that by watching some other videos. You probably need the formula for this one, since the derivation might be a little more challenging. So what is the formula for the the volume of a sphere? Well, the formula is 4/3 pi times the radius cubed. So if we take 4/3 pi, and then our radius in this case is 8 inches, and we put that into the formula, then we cube it. So notice that I left it as a fraction, 2048 over 3 pi inches cubed, or I could say 682 2/3 pi inches cubed. Notice I used the exact volume for all of that. I didn't even put a decimal there, so we would make sure we had the exact answer. When we approximate, we will put some approximation in for pi. Sometimes we use 3.14, sometimes we use the pi button, our calculator. Sometimes we even use 22/7 for pi, which is another approximation. So if you approximated this volume, it would be approximately 2,143 57 cubic inches. And for that approximation, I used 3.14 for pi. I hope that helps you see how you can use formulas when finding the volume and attend to precision with the exact answer as well as an approximated answer. Thanks for watching.